If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE-sponsored podcast.
We love SPE. We're here at Antech. It's the last day of Antech. It shows.
We're punchy.
Yeah. But I'm Mercedes Landazuri. And with our powers combined, we are PlastChicks, the voices of resin.
And chaos.
And chaos. And chaos. We don't record the first Friday of every month.
No, we record it all chaotic times.
Yeah, all chaotic times. And usually over Zoom, but we're fortunate enough to have met some fantastic, brilliant people at SPE Antech.
And if you are at a networking event and you are having a drink, they are much more likely to say yes.
To recording a podcast interview with us.
Yeah. So, insider.
So if you're not watching us on YouTube, if you're just listening, we do have a very kind gentleman with us today who's sitting in between us, who is being completely ignored by us. Just to give you a little visual there.
So today we have Jake Kelly-Walley.
He is a PhD student at Queen's University, Belfast, and also an R&D engineer at Matrix Polymers. So, Jake, welcome. Thanks for coming on the pod.
And thanks for making us international.
Yeah.
They're international, but
thanks for helping us stay international.
Yeah. Sustainability and internationality.
Mrs. Worldwide.
That was Pitbull.
If you could just, if you could edit in a foghorn, not a foghorn, what's it called? A klaxon. Yeah, it's an air horn. Yeah.
Well, that makes a lot of sense. So, bringing into you this week, not really having met you before, and I think we just crashed your table at one of the networking events.
No. Well, I sought you out. Oh, no, you met him. You crashed his table.
I crashed it.
Meanwhile, I was on the swap card app looking through all the talks, and your talk particularly caught my eye because I know our good friend John Ratzliff, who does a lot of work with rotational molders, was talking and is on the recycling division or recycling technical interest group. He had talked to me about the difficulties of. Well, we'll get into your. I don't want to give it away, but I was like, we got to talk to this guy because what he's doing is pretty cool.
Come to Antech for those that don't know. It's really presenting on something you've been researching, or maybe your company's been doing with a new technology, and so you're here to kind of present how that's going or what's going on, or sometimes you're here to kind of seek more answers. So your research interests, tell us how they kind of align with the UN Sustainable Development Goals. I mean, we're going to throw that out there. That's a big question to start off with. We're here for it.
I guess a lot of the sort of sustainable development goals at the moment are around like responsible consumption of materials. Polymer industry is like fairly heavily kind of criticized in the media, let's say. So my research at the moment is looking at introduction of PCR into the rotational molding process, so post-consumer recyclates, things like that. So we would be using material that already exists, potentially increasing value of that material by using a rotational molding. I guess the other parts as well are like introduction of biopolymers, biomaterials, and more natural things like natural fibers as well.
And it just dawned on me, you might be our first rotational molder on this podcast.
Yeah, well, that's one of the benefits of this conference is you have all the different divisions, people from, presentations from, and you and I don't really do much with rotational molding at all, so it's kind of a blind spot to us. But I knew because of John Ratzliff how uncommon it was, how much it is an R&D thing these days to try to get more PCR into rotational molding. So that's what excited me about your presentation title. And I asked you at the networking hour because I didn't get to attend your presentation, unfortunately. But can you tell us a little bit about? I said, well, does it work?
Yeah.
Because sometimes you see papers at Antech, and it's like, and you get the end, and it's like, and it didn't work.
Sometimes not knowing what not to try.
No, I guess so. What I was looking at mainly in that study is like restabilizing. There's a lot of like things in the literature at the moment, and I think it was kind of quite heavily reviewed in like the 2000s, where people are kind of stabilizing recycle again. So deem the term restabilizing. We were introducing recycler that isn't from the rotational molding process, from blow molding, into a compound that's specifically designed for the rotational molding process. Problem we have is those resins are kind of stabilized for blow molding. So I mean, how long are you above the melt temperature for blow molding?
Right.
A couple of minutes, perhaps, maybe maximum. In rotation molding, it could be like half an hour, 2 hours. Depends on really what you're molding. Some things are enormous. So what we wanted to understand was actually we need to restabilize these materials because they were never stabilized to withstand this in the first place. And when they've been recycled, you're consuming that antioxidant anyway. So we need to restabilize, but how do we restabilize? And is there sort of specific ways which are more effective? So we had a look at some specifically designed restabilization packages from additive suppliers. We had a look at sort of typical ways with primary, secondary blends. And we also had a look at some acid scavengers as well. In terms of did it work, we saw like quite a 30% increase in impact performance, which is pretty cool. In that sense, impact performance is particularly of interest to rotational molders. And I guess what people will be doing as they use more and more recycling is trying to benchmark against virgin materials, which is difficult because I would say some general purpose applications in rotational molding, they've only ever used virgin materials, right? So that is, I guess, the specification. But a lot of the times, maybe the application doesn't need that. So we managed to increase the performance at the same PCR percentage, which is fantastic. And I guess now it's kind of exploring, which applications don't need the virgin level that we've been used to for, 20, 30, 40 years, which is,
Yeah, I think that's a problem across like all the processes. Is saying, let's benchmark all this PCR stuff against the original, and it's like, well,
Right.
Yeah, of course.
It's not that same.
Yeah, and with the generational gap that we have in the industry, a lot of the people who originally wrote the specifications are maybe retired. Maybe that knowledge has been transferred as to why those were the specifications.
Yeah. And there's if there's not a need for it, like you may have to like start from scratch to rewrite that and reestablish where you're going with that product or what you need out of that material. And you're going to have people that are going to say, no, well, it has to be this virgin material because of what
it says
it did.
there.
Yeah,
because it says.
So you're going to have that too. And so that's a very hard hurdle. I think a lot of people, like if you're outside the plastics industry, you're not even seeing that hurdle as like your jump into becoming more sustainable.
Yeah, it's like a technical consideration, right? And it's definitely one that needs to be made and shouldn't be taken lightly. But of course, if we've been used to sort of Ferrari, but we could drive, I don't know, the Ford, in that application.
So how was your paper received? Did you get some questions?
Yeah, I got some good feedback in terms of, what we would be looking at afterwards. Also, this study was pretty industrial, so sort of more applied to material development, let's say, in kind of an industrial sense. One thing that has enabled me to do is kind of scratch the surface on, really the proof is in the pudding because we measured the mechanical performance, right? But to find out what's actually going on inside the material, I can have a look a bit further inside the PhD. So sort of sussing out a bit more in terms of the degradation, using a few other techniques, maybe looking under the SEM to have a look at the morphology as well. So that's something that I'm excited about, to take those parts which I already have to the university and also at Matrix and have a look a little bit further.
So that was actually what I was going to ask you. You have these two positions. You're working on all this stuff with your PhD, and you're also working part-time at Matrix right now. How do those two things feed each other? Like, are they very, handshake? We're good. I'm making a handshake.
Yeah,
we could do that.
Or is it things where you have to prioritize what's going on at work and then prioritize what's going on? How do you balance it?
Yeah, it's a very, very good opportunity for me. I'm very grateful for Matrix for sponsoring the PhD and allowing me to do both at the same time. And they go very nicely hand in hand. Like, for example, in terms of my role as R&D engineer, I visit a lot of customers, see a lot of molding trials, understand actually on the shop floor what is going on, and also what materials they might need or challenges that they face, and they say, oh, we need this, or maybe they need a new solution. So that kind of feeds some ideas into the PhD. Equally, on the other hand, I work with a lot of academics at Queen's University of Belfast. They have a fantastic rotational modeling group there, historically and today as well. They're very active. So again, that feeds very nicely into practices that I conduct for material development. So yeah, that's pretty cool.
Just reminded me that when I was in college, my one professor, John Meckley, who's since passed, he told us about a rotational molding program. And he's like, it's overseas. You got to go far away. He's a weird guy. And
He's a wonderful guy.
He was a wonderful, weird guy. And it was getting your doctorate in rotational molding.
Okay, maybe at Queen's.
I am now just making that connection. I think this
don't cry, Lynzie.
Well, no, I won't cry because it was a Meckley. It's a good idea.
Yeah. What a small world. Yeah.
Now that I take my track, very nice.
Yeah.
So, Jake, what motivated you to focus on developing high stiffness polypropylene foam as an alternative to existing polyethylene foam grades?
So that was a presentation I gave at Antec. Well, I was supposed to come. That was going to be my first Antec, but unfortunately, it had to kind of go online. But yeah, that was really a motivation around just to see if we could push kind of the boundaries in terms of performance. For that particular material, there's a lot of applications with foam and rotational molding for kayaks and boats and like multi-layer structures. So we were thinking, actually, could we, make those a little bit stiffer, increase the level of performance, both for, I guess, recreational, but also more for like performance sports, Again, it was a pretty cool application. We got some really good results, and we're still reviewing some of those now, and looking for different applications. So
very cool.
And speaking of multi-layer materials,
very nicely this year.
Word on the street is you have actually you can speak to banana fiber multi-layer.
Oh, I was so excited about this. Yeah, banana fiber. Let's go.
Yeah, tell us first of all, whose idea was that, and second of all, like, tell us, what's the mechanical properties, like where do you see the applications for this?
Yeah, so in that one, like, this was kind of pre-existing quite a long time before I started the PhD, and it's collaboration between Queen's University in Belfast and also the University of Las Palmas in Gran Canaria, Spain. So they have a fantastic group, and they do a lot of work around fiber research. They have a lot of invasive species on the island, which they're trying to kind of make use of rather than just putting down and go to waste. So the banana fiber, I think that was going on, kind of 2013, maybe even a little bit before. So it was a nice project for me to get involved with Zaida Ortega. She's a professor at the university in Gran Canaria. So yeah, basically we were incorporating the banana fiber, which is waste from the process. So it's not kind of competing with any feedstock or anything. It's literally just waste. Yeah, exactly. So it's fantastic use of those resources. And yeah, we incorporate them either by melt compounding or dry blending. And there's two considerations there, because obviously you might thermally degrade the fiber if you pulverize with the material, because we use powder, right, in rotational molding. So you're kind of changing the aspect ratio, changing the fiber dimension, changing the properties. But we got some stiffening behavior of the materials. One thing we were interested in is the multi-layer structure, but of course that led to some increases in cycle time, which may not be preferred. But really, we're just trying to see, compared to the virgin materials, what level of performance we got. The problem we have, particularly in that study, was we saw a reduction in impact strength, because maybe we get more pathways of propagation.
Depending on how they were oriented.
Yeah, and we kind of get more random orientation than the shear processes, because shear, you can align them pretty nicely. With force. Yeah, we are just relying on the polymer to relax and the fibers to be in the tool there. So.
Interesting. And so, because when I was selling special effects raw materials, there's always issues with rotational molding, because it's depending on the specific gravity.
Yeah.
So was the banana fiber concentrated on the inside of the?
So in this study, we looked at melt compounding. So actually, we predispersed it, and in which case, really we get fairly a nice sort of across the cross section. With the fibers, I think, if you dry blend them, you do tend to get this migration to the internal surface, because basically you're kind of like sieving the material almost as it's kind of going around the tool. You've got the gravity as well. So yeah, that can be a challenge. And for some dry blended things like pigments, and so we can potentially see a reduction in properties if we don't melt compound. So yeah, it depends really where you get them. And if you have a multi-layer, you can kind of re-encapsulate them. But of course, you have like a longer cycle time, these kinds of things. So, but yeah, Zaida and her group there have done loads of work on lots of different fibers like giant reed, banana, and there's a lot of other invasive species as well. So they're really trying to make use of it, not only in rotational molding, but other polymer processing methods.
And so you're not processed too high, right?
No, I mean, well, that was one of the comparisons we drew. I mean, the material that we had was melt compounded a while back at some specific conditions. But what they had to do was really lower conditions to prevent any of this like oxidation, thermal degradation.
Yeah, on the design side, I see a real interest in adding these, upcycling waste into plastics. But all the injection, people who are making injection molded parts want to do it, and it's like, no, it's not gonna, it's not gonna hold up in nylon.
What do you mean?
Yeah.
So is there anything else, coming up in your research, or any advancements, discoveries in, the rotational molding field that's really getting you just as jazzed as banana fibers?
Yeah.
Jazz hands, banana fibers.
Yeah, I mean, my research mainly focused on that's something that excites me because there's a lot of challenges. Like I mentioned, materials that are abundant are coming from like our typical home household waste. The materials that are consistent are also coming from the same feedstock, right? But they were never designed for rotational molding in any way. We're talking like fractional melt materials, very high viscosity. They don't sinter. So trying to incorporate them into the process is like a real sort of effort in terms of modification of those materials. But what excites me the most is actually there's a lot of value associated with that. I mean, recycling, I guess our objective as an industry is to maintain the value as long as possible, right? We recycle once, we try to reduce any reduction in properties, things like that. Rotational molding, if we take those materials that maybe would be, reducing in property, reduction in value, or maybe they go to landfill, if we incorporate them to rotational molding, we can incorporate quite a lot of material in one part because we have larger shot weights. And also rotation molded articles are in service for quite a long time. I mean, I was at a hotel actually in St. Louis. I went for a coffee and they had some like a rotation molded penguin and a wolf and things. And you think, this is art. It's like a very nice high value application. And imagine, you can incorporate quite a bit of PCR as well. So I think, understanding how we can improve processability, but also, I guess, increasing performance of a blend with a certain amount of PCR, or maintaining performance and increasing the PCR. I think there's a lot of value behind like being able to use those materials.
Absolutely, and I love the idea of making art with it, where it's like, okay, you don't need there's no specs for art, right? Like you can.
What do you think the specs should be? It's not that.
Yeah, and it's. I mean, this is like getting off topic, but like a Patricia Miller Matrix, 4, how they M4. How they have their artist in residence program making art with their like waste materials, their injection molder. Off topic, but
how sort of on top.
Yeah, I was guys. How did you? We only met you here at Antec. We know nothing about just the research that we've done just last night this morning to interview you. But how did you? What's your story, kiddo? How did you get out of this field?
Yeah, so I mean, I started maths, chemistry, and maybe like processes, which you don't maybe see too much of at like high school, for example. But I was interested in that. I went to a few open days and I thought maybe this is the thing for me. So I went there. I was there for kind of 3 years. I graduated. And then I was really looking for like some practical experience. Luckily, like Matrix offered me like a short position for a couple of months. And that was my first exposure to rotational molding. I knew a little bit about it before because I did a bit of like product design and things like that. But so I went there, obviously, polymer processing and chemical engineering are quite closely aligned. So I was like, wow, this is this is pretty interesting. I really started to enjoy it. And then I was actually, I wasn't supposed to stay for so long. I was going to go back to university, and I thought I'd really like to stay here. So I was lucky enough, the guys at Matrix, Aldo and Martin, who's our CEO, I managed to stay for a little bit longer, where I did my master's there also. Another university which is focused a bit more on polymer processing, which is Loughborough in the UK. And then I completed my master's, and I was around people who had done PhDs. I'd been exposed to at university. I thought I'd also like to try this. And again, Matrix is very supportive. I think it says a lot about Matrix organization in the sense that they are very research driven. We only focus on rotational molding materials. We don't supply any of the polymer processing methods. So it allows us to have this quite intensive focus on development of new materials. I guess the PhD complements that quite nicely as we collaborate with various universities and things. So yeah, it's exciting.
Yeah, it's really nice that you found a place that would really support you the whole way through the journey, because there are a lot of people that, have to take the time off, and they're like, well, I'll be back. And by the time you come back, is that really worth it?
And it's really nice for us that you found your way into plastics. I mean, because this is some really exciting stuff that you're working on.
Right, that we don't hear enough about.
Right.
I mean, I can't tell you that much about rotational molding, except that it rotates. I knew the powder part, and I think that's about where my knowledge of rotational molding.
So how much longer would you say you have left with your PhD?
So I should be finishing the PhD in kind of 2026.
Okay.
So I'm at the stage now where I'm collecting a lot of experimental results, really understanding and demonstrating, I guess, because the rotational molding literature is not maybe as expansive as the other process methods. There's a lot of fantastic work done at Queen's, but also all around the world, in Europe, New Zealand as well. Professor Roy Crawford, I think, really pioneered some scientific research into rotational molding. But yeah, in terms of papers to refer to, the quantity of research is maybe a little bit less. So to start off in terms of the PhD, I really want to demonstrate to maybe other polymer processing methods, other professionals, right? This is the problem we have, you can see it now. And then really go in to focus on, right, let's draw from other polymer processing research, other ideas that have been successful in injection, blow molding, even 3D printing, perhaps. Okay, there's other considerations because we have no shear, we have no pressure, and it's a very different process, but maybe we can take some of that good work from other people and try and implement it for us.
I mean, this is kind of exciting because I feel like you're kind of pioneering a lot of stuff. Normally we're talking to people that are a lot further along in their journey and are we talk about yes, you have been so amazing and badass, and we will sing your praises in this industry for years to come. And I feel like you are at a very young part of your career, and we're already well, that was a lot. So I am going to exploit this relationship now. I will constantly refer to you in all my rotational talking.
Thank you. But it's not just me. In terms of Matrix, we have a lot of material development experts. At Queen's, they have people working not only on materials but also process applications and things like this. Also, university in Gran Canaria in Europe, in the US as well. I've had a lot of good rotational molding research, and Antec has allowed me to facilitate that a bit more and have those discussions. So,
do you get super excited when you see another rotational molding? I was gonna say an injection molder. You gotta have a name for it. Yeah,
processing pride.
Processing pride.
Processing pride.
Hashtag roto. We'll come up with a hashtag. We'll figure it out.
Absolutely. Rotational molding is obviously the best polymer process method, right?
Oh, Lynzie, she's constantly saying, I think it's fascinating, but it's kind of a mystery to me.
Yeah.
I've never had one in a lab because a lot of times color labs don't have them unless they're focused on rotomolding color, which is a totally different beast. This is why it's such a mystery to me. Have you had to do some rotomolding in college?
Very small scale rotational molding. Not in college, but in my high school. We had a very tiny little rotational molder and dumped the powder, and it was a little elephant. It's probably still kicking around at my parents' house somewhere.
It's
Wow,
fascinating.
that's pretty good.
It feels old school, which
Yes.
is what fascinating. Well, you have like all these innovative things that you're working on, but it also and mysterious to me, but also I mean you can make the biggest parts with them. I think Penn College Technology here in the States, a lot of those guys I think because they're sponsored. They have a big sponsor from Toter, one of the big rotomolders here. So I think a lot of the people who graduate there end up in rotational molding, but it's kind of a blind spot for us.
Yeah, I think in my class, like one person did like an internship at was it Two-Step, the
Toy
toy place, yeah.
manufacturing.
But I don't even know if they do that anymore. Anyway, that's but yeah, so it's one of those things where I mean injection molding is obviously the best process. But
I'm undecided.
so how do you what advice do you have for students that are maybe looking to get into the industry? How do you draw them into rotational molding instead of letting them slip through the beautiful world of injection molding?
Or material science or yeah.
I guess one of the big things is you have to see it, right? I mean, until you see things that are existing in the industry, I guess as a young graduate, you don't exactly know, what is there. You might read a little bit about it or see it in the textbook, but until you see it in real life and the potential of those process methods, then I guess, yeah, you don't know. And one of the things I would say is like rotational molding is changing quite significantly in terms of the process. There's a lot of kind of electrically heated tooling now, even like a lot of automation and things like this. So, what people maybe see in rotational molding textbooks or historically is very different to maybe some of the new developments in the industry now. So if people are able to see those as well, students are able to see those. It's a very advanced manufacturing method. So I think, being able to see it and allowing young people to come and have a look at the universities or even manufacturing facilities, speak to engineers who are really delving deep into process parameters. What does this mean for the material, crystallization, viscosity? How does it affect the process? Then I think you'll have a lot of people being interested.
Yeah, that's true. Because if you go and see like a big, huge something or other being rotationally molded, you're like,
it's pretty cool.
So you're talking about all these things that we hadn't heard about in rotomolding. How do you stay updated with the latest trends and developments in the field?
Especially if it's moving so fast.
Yeah.
I mean,
but like, I'm thinking that's a joke because
Oh yeah, I mean, in Europe, there are a lot of regional groups with conferences. Earlier in January, I didn't attend, but my manager, Dorana Jaiwarden, he attended the Nordic Arm Conference. There's like various ones throughout Europe and UK. We had a very big one in September last year in Poznan. But there's also there's one in the US later this year, I believe, Rotoplast, things like this. So really, someone will go and report back in terms of new developments and things like that. There's also like a lot of reading material. There's Roto World, a magazine. And yeah, I guess generally, news outlets that people have tried with rotational molding, different newsletters from the ARMO as well, and things like that. So it's really, that's quite nice because you get to see pictures of kind of very new applications, niche applications that maybe you never considered before, or you'd heard about a couple of months earlier that it was in development. You see, they've had a great deal of success now, and and really thinking about what materials they're selecting, why they've selected those materials, and what that means, and really just reading all you can and seeing all you can from the wider.
I'm getting excited about rotomolding, man.
I read rotational molding groupies now.
We might be group. I think we're groupies because we're like,
we can't.
We're like,
not in the club.
No, we're with the band. We're not in the band. We're with the band.
With the band.
Yeah.
Everyone's in the band.
So we're almost out of time, but how do you envision your research? I mean, I think we kind of touched on this, but how do you envision your research making a lasting impact on not just your industry, but like society? Here's a big, lofty question. What are you going to do for the future generations?
Yeah, how are you going to change the world
today?
I guess we have to take it as yeah. Everything. Also, there's many ways more sustainable, and I guess whichever direction you take is kind of solving a different problem that we face at the moment. So it might not be moving towards significantly one way, but it might be moving a little bit the other. So I think, yeah, I mean, use of recycling and rotational molding is a nice way to combat the plastic pollution problem. In some scenarios as well, maybe reducing carbon footprint of manufacturing processes methods. Introduction of biomaterials, of course, yeah, you can reduce carbon footprint and things like that. And there's a huge amount of value because, of course, manufacturing consumes quite a bit of energy to get different products. So yeah, I think it's just step by step in each direction, what sort of small improvements we can make and keep improving on those. Of course, it'd be nice to get this giant leap, and I guess that's what we all aim for in terms of like our research and things. We want to really make an impact, but I think really we go step by step. We begin to improve, and then even in a short period of time, we can have a significant advancement in terms of materials, the process, and it's pretty exciting, right? Because we've been addressed by a lot of problems, and it's good to have them because it means we can make an impact. Something I'm quite excited for the next couple of years. I'm sure you guys are as well.
We are, and now you just listed out your three-pronged approach to solving world problems with plastics.
Yeah, maybe don't refer to that. Yeah, that's what we should do.
Well, Jake Kelly-Walley, it's been a real pleasure. Thank you so much for joining us today, and didn't talk too much about what really your plans are for the future, but I'm excited to follow your career.
Oh, thank you so much.
And your
Thank you for having me.
Yeah, thank you.